Hello everyone, welcome back to my channel. Today we will solve floodfill problem. It's a LeetCode number 733 problem. So the problem statement is that you are given an image represented by m cross n gradient of integers. So basically it is a 2D array where image of I of j represents the pixel value of image. So yeah, pixel value you can consider it as an integer only. Okay, you don't need to think about that much. You are also given three integer sr, sc. Sr comma sc is a coordinate of like source. Okay, so in 2D array you need I comma j coordinates for to pinpoint any location. So yeah, sr comma sc is a source location and the color is given. Okay, so you need to go to sr comma sc and you need to update the color. Okay, so your task is to perform a flood fill on image starting from pixel image srsc. Okay, so srsc is a source. So let's read an statement by statement. We will simplify for ourselves. Okay, so what's it begin with the okay source is sr comma sc. Okay, the color is given and okay from sr comma sc. Okay, you can move adjacent pixel let's share the same side with okay, so from sr comma sc you can move vertically up, vertically down, vertically right, vertically left, and okay, you let's say you can see. So here pink. Okay, so the color of sr comma sc is 1. Okay, the given the old color. Okay, so there are two type of colors. One is old color, one is color that the new color needs to be updated. Okay, so src comma sc previously has 1. Okay, so old color is 1, we can was equal to 1. Okay, and new color we need to update it 2. We will update the sr comma sc 2. Okay, then we will go to the left. Okay, right, currently we can see okay the top, and here it is 0, here it is 0. Okay, so currently the scenario is this: we have updated the srsc to 2. We will go vertically up if it will have same color. So there is a condition: if it will have a same color then we will update it to 2. Okay, so we will go there, we will update it to, we will go here, we will update to 2. 0 is the same color as 1. 0 is the old color, no, so we will not be. 0 is the old color, no, so we will not update. Okay, so like this we will report, like this we will repeat the process and we will return the final matrix that we have. Okay, the final image that we will have. So this is the question. So the question is actually easy. So but why I picked up this question is because this question comes under two scenarios. First one is you want to solve it via recursion. Second is you want to solve via dfs. Okay, which comes in graph. Okay, so basically both are the same, only dfs is a kind of recursion only. By this problem we can show this, we can show that. Okay, if I will ever like start a graph topic, then I will pick this problem and I will like relate how it is related to dfs and everything. Okay, now so so it's a recursion problem, we know this much. How we know this is a recursion problem? Okay, so as you can see. Okay, so recursion is a like a function calls itself. Okay, it's a like modular definition of recursion. Okay, but for us, okay, if a problem is repeating or a work is repeating, okay, then we will call this problem as a recursion. So you can see your work is repetitive here. What is your work? You are going to source comma, you are going to first, you are choosing a source. Okay, you have given a source, you will update that color, you will move in all four direction. Okay, you will update their color. Okay, then the next updated coordinate will be your source. Okay, so again you will repeat that work. So basically you are repeating that work here, so that's why this comes under the recursion part. Okay, so okay, uh, so what we will, okay, so we got into issue why it is a recursion problem. So what we will discuss here, okay, we can write pseudocode. Okay, we will discuss TC and SC. We can discuss about recursion tree also for any of which one statement. Do we need to think of anything else? Okay, no. Before pseudocode, okay, so when we think of recursion, okay, then always we need to think of a base case here. Base case. Yeah. So basically you have a matrix. Okay, your source is this. Okay, you have updated the color here. Okay, now you will move this direction, you will move this direction, you will move this direction. Okay, let's say you have updated the color here too. Okay, now you will go this direction, you will go this direction, you will go this direction. Okay, so what do you think, what will the base case when you cross this boundary? Okay, when you cross this boundary, then what you will do? Then there is a no element present here. This is basically a compiler error only. Okay, that you are accessing something out of bound. Okay, so it will give a runtime error. So okay, so this boundary check condition, you cannot cross the boundary. Okay, so first would be your boundary check only. Okay, now the second thing, okay, let's see this matrix. Okay, you have one here, you, okay, we will 1 1 1 1 1 0 1 0 1. Okay, so you have gone there. Okay, you have updated this color to 2. Okay, now the matrix is this. Okay, now you will go to the 4 direction. Here you will update it to, here you will update it to, here you cannot do. Okay, okay, now you are here only. Okay, so you will go this side only, you will go this side, you will go this side, you will go this side. When you will go on back, go back to it again, because you are not thinking now where you are present. Okay, you are doing, you are going in all production, then from the upward point, when you will go to the downward point, okay, then you will come back again on this time, on this coordinate. Okay, on the source. So will you update this color again? The answer is no, because the color is not same as a old color. Okay, so but here you got saved. Okay, I will tell you why you are saved here. So when you get back to this, okay, so you have updated the color. Okay, so actually this is marking this cell as a visited, that you have visited it again. Okay, so in the graph, okay, in graph here the only logic changes, the logic changes that you will have a visited matrix that will take care whether a coordinate or whether a node is visited or not. Okay, in a graph you have a visited matrix. Okay, so but here recursion can be applied. Okay, you can have a like separate visited matrix here also, in this code also, in recursion only. Okay, but what I'm telling you, that here if you're not having a visited matrix, then also okay your problem will be solved, because this changing, this updation, okay, this updation will tell you that yeah, this coordinate you have visited, you don't need to visit it again. Okay. So, and how can you check that updation? If the color is same as the old color or not. Okay, so second condition can be color is not equal to old color. Okay, color at coordinate you can say. Okay, so these are the two base condition. Okay, now let's write the code part. Okay, I will write pseudocode only. Okay, so this is a like easy code, you can search it online. Okay, so what we have I guess in the statement. Okay, we need to return vector of int. Okay, the function name is floodfill. Okay, here vector okay image is given. Okay, int sr int sc, sr comma sc is given, and yeah, new color is given. Okay, so basically you can make a copy matrix also, because you don't need to update the input. Okay, but I'm generally use like interviewer will like that if you make a copy matrix, because the updation of input should, it's not like a good habit, it's not like a good practice. Okay, you should not update the input what you have got. So basically you can okay have a copy of image here. Okay, now okay, so we have discussed base case. Okay, for that base case we will have one function. Before that we are not given with the old colors. Okay, so we will store old color. Okay, what is old color? Old color is color at src sc location. Okay, yeah, do we need anything more? No, it okay, we have sufficient information. So let's say our function is help. Okay, we will pass image. Okay, do we need visited matrix? No, we don't need visited matrix here. Okay, we will pass source, we will pass color, we will pass old color. Okay, one thing you can pass n comma m. Okay, which is like or you can get it from image only. Okay, sorry, I should pass copy image here. Okay, yeah, now it's okay. Now we will write this help function here. Okay, so bvi, you can understand it is a vector of int. Okay, copy int sr int sc int color int o color. Okay, so first we will write the base case. What is a base case? Okay, what was our base case? Base case was that we need to first check boundary condition. Yeah, so for boundary condition, if okay, so where you are currently located, you are currently located at source. Okay, and when you will traverse like vertically up vertically down, then it will be your source. Okay, so your current location is sr comma sc. So if sr is less than 0, means if your index have if your row have been, if your current row have gone below to 0, it means you are on negative side. Okay, or you have exceeded the size for this copy dot image, the max row present in the image. Okay, or your column is less than 0, or your column have increases the size of the max column present in the image. Okay, then what you will do, you will return, simply you will return from here. You don't need to do anything here. Okay, this is your base case. Okay, now second base case, what was that? Second base case was that if your copy srsc, what is this? This is your current color. Okay, it's not equal to old color, then will we update this color? We will not update anything here, so we will return. Okay, now the only thing is return to call the recursion. Okay, so you have called this like this recursion here. What you will do, you will copy this 4 times, you will update the rows and column accordingly. Okay, now I will do that. Help, okay, copy srsc color, old color. Okay, simply, okay, I will change, everything will be same. What will change? This sr and sc. Okay, so okay, you have updated the current. Okay, now you will go vertically down, you will update one. Okay, then you will go vertically, sorry, you will go vertically right. Okay, then you will go vertically up, then you will go vertically left. Sorry. Okay, this is a 4 case. You can do in loop also. You can, for 4 operation, you can do it like this also. Okay, but we will return here copy. Okay, we will return copy answer here. Okay, so your okay, now we have done all this. Where we have updated the color, we haven't updated the color yet. Okay, where the copy is changing, we have written base case, we have called the recursion, where is copy updating. So here only, after this base case, okay, what we will do, we will update this color, okay, to new color. Simple. Yeah, so I have kept it to last because I wanted to show you where copy will get updated. Yeah, after that you can return copy. Okay, so any guess about time complexity and space complexity? Okay, so generally, okay, let's say if you don't have any you have mm, you don't have anything to mark it as a visited or identify whether it is a visited or not. Okay, whether any coordinate is visited or not. So every coordinate would have 4 options. Okay, for 4 option you have n cross m. Okay, m, you have 4 options for one coordinate and you have n cross m coordinate. Then ideally it would have been this tc. Okay, ideally this is not it. Okay, but here you have criteria to mark to identify whether a coordinate is visited again, so you won't be visiting it again. Okay, so why, if we won't be able to identify, okay, whether it is visited or not, okay, then we will repeat that, okay, step. We will repeat the process for that coordinate also. Okay, and that extra space will lead to this much complexity. Okay, but here we have criteria to identify whether an coordinate is visited or not. Okay, so in that case it will get reduced to n cross m. Okay, so why n cross m? Because every coordinate is getting visited once. Okay, every coordinate is getting visited once. Okay, you're not like you're not visiting any coordinate like 2 times or 3 times. Okay, so this won't be answer, this is your correct answer. Same with space complexity, you are making a copy image here. Okay, so that will lead you to, like, yeah, you are making a copy image here. Okay, and you can have a recursion stack space, like, so order of it will be your, you don't need to count here. Okay, the recursion stack space. Okay, so yeah, we have dealt with SC and TC. Do we need anything else? I think we can talk about one recursion. Okay, one recursion tree. Okay, for this input only we can talk. Okay, so if we see what is SRSC, SRSC is 1 1 and color is 2. Okay, okay, so we will start recursion tree. What happened? Yeah. Okay, so DFS. Again, I'm writing DFS. Sorry. Yeah, this is our function. Okay, help. Yeah, we have SR1, SC is 1, color is 2. Okay, we have a matrix. Okay, I will make a matrix here. What was the matrix? 1 1 1 1 1 0 0 1 1 1. Again I forgot. 1 1 1 1 1 0. 1 1 0 1 0 1. Okay, yeah. Okay, I will show only few steps. Okay, rest all thing can be generated. Okay, so here we are help. Okay, we have copy image, we have 1 comma 1, we have color, we have old color also. No, so old color is 1 only. Okay, now we will go here, we will check whether SR is 0. We will check boundary condition. Okay, is this coordinate a boundary? No, it is inside the matrix, so yeah, it won't get failed. Okay, now we will check this condition. If image of S, like copy of SRC, S is not equal to old color, so copy of SRC is 1, 1 is equal to old color. Okay, so 1 is not equal to old color, this condition doesn't get true, so it won't get written here, so we will go here. Okay, now we will update this. Okay, so again, what happened? Yeah, we will update this. This will become 1 1 2 1 1 0 1. Okay, we will update it. Okay, now what we will do, we will call this recursion, this step. Okay, this one first, SR plus 1. Okay, so this will call help. Okay, in this step what have been done, this got updated. Now we will call SR plus 1. Okay, 1 plus 1 is 2 here. Okay, 2 comma 1 current. Okay, color is 2 and old color will be same. Okay, okay, now we will go into this function. Okay, we have got this step. Okay, help 2 comma 1 2 comma 1. Okay, now we will check whether it is a boundary condition. 2 comma 1, so 2 comma 1 is this. Okay, 2 comma 1 is a boundary. No, it is not a boundary, so it won't return from the base case. Then it will go check whether this color is not equal to old color. Yeah, this color is not equal to old color. Okay, 0 is not equal to 1. Okay, so it will return from here. Okay, but your matrix is like 1 this now. Okay, because your matrix passes reference, so it is getting changed. Okay, now it will call. Okay, now this step ended. Okay, this step ended. Now we will call this step. Okay, Here what is updating? We are updating the column here. Okay, so yeah, help 1 comma 2 comma 2 comma 1. Okay, now what will happen? 1 comma 2 is a boundary whether it is filling as a boundary. No, it is inside the matrix, so it is not filling as a boundary. Okay, whether this color 1 comma 2, what we are doing, 1 comma 2, so in this 2, okay, this color whether 0 is equal to 1 and 0 is not equal to 1. Okay, so yeah, this is filling our base case, so it will get returned. Now the third function will call, what is this, help. Now what we are updating, now we are doing, okay, this function gets done. Now we will doing sr minus 1. Okay, 1 minus 1, 0 comma 1 comma 2 comma 1. Okay, 0 comma 1 is inside the matrix. Yeah, it is inside matrix. Okay, what is the color of 0 1? Color of 0 1, 0 1 is 1. Okay, this one. Okay, so color of this 0 1 is 1. Okay, 1 is not equal to 1, 1 is not equal to 1, it is a false, so if we want return from here, what we will do, we will update the color. Okay, now we will update the color. What will happen here? One two one 1 2 1 0 1. Now this will be updated to this. Okay, we have updated this. What then? We will go deeper into this. Okay, now for this, okay, we have updated the color. Now we will call the next function, help. What in so next function, help, we will call this step for, okay, for our new source sr plus 1. Okay, so help 1 comma 1 2 comma 1. Okay, so here comes the visited part. Okay, it is already visited. 1 comma 1 is already visited. How we identify? We will identify with the same condition that, yeah, 1 comma 1 is a color is a 2, color 2 is not equal to 1. Okay, so we will return here a base case, we will return, but yeah, it is a visited condition. Okay, now we'll go to the next step for this coordinate 0 comma 1. What is the next step here? We will do help. Now we have increased this, we will increase this 0 comma 2 2 comma 1. Okay, 0 comma 2, where is 0 comma 2? 0 comma 2. Okay, this one. Okay, okay, what is happening? Yeah, 0 comma 2 is this. Again, so it is a boundary check. It will pass, like, it is inside the matrix, so it won't get failed in boundary check. Whether this color is old color, yeah, it is a old color. Okay, this color is not equal to that condition will fail, so it won't get returned from there also. Then we will update the matrix 1 2 2 1 2 1 1 0 1. Okay, now once we update this, okay, now we have updated this here, so we will get again into here help 1 comma 2. We will now, this is our new source. Okay, first we will complete this. Okay, so you can see we are traveling in depth. Okay, we have started from here. This is like our new source. Okay, then this become our new source. Okay, then this will become our new source, so we are traveling in depth. Okay, okay, so that's why in graph it is called DFS, depth first search. Okay, you are traveled into depth, then you will return to here, then you will explore other conditions. Okay, so you can see first you have traveled this path. Okay, you can see you have traveled this path, you didn't get anything, you travel this path, then you will travel completely this path, then you will return here, and you will do like, yeah, help 1 comma 0 2 comma 1, then you will explore this path completely tens. So this is kind of a, yeah, so this is like a complete recursion tree for this. It is not clean as it is, but yeah, this is all. So we have covered TCNSC, we have tried this, we have written down the code, we have written down, we have explained the statement, TCNSC is done, recursion tree is done, yeah. So that's all. Okay, so I have also explained you how it linked with graph.